In this episode of Turn Stories, I sit down with Anthony Sottile, who led Lyft's migration from Python 2 to 3. They did 150 services in less than 6 months. But what stood out wasn't just the scale or the timeline, it was the approach. They really leaned on tooling so they could ratchet progress forward, and then they'd lock it in with CI rules so nothing backslid. They would ship automated PRs, and if nobody complained, but nobody looked at them, they would just purge them. And they trusted their infrastructure. They would do deployments where even if there were errors, they knew the system would retry and there wouldn't be any user visible impact. And that made for a really powerful migration story. So we talk about what worked, we talk about what didn't, and some of the most hilarious failures across a couple of key services. We talk about what tooling and patterns you could take from this to make your migrations work like they did. Enjoy! Today, we've got Anthony Sottile today on the show, and we are going to talk about the Lyft's Python 2 to 3 migration. Anthony has worked at a ton of awesome companies, Yelp, Stripe, Lyft, and now works at Sentry. And I'm excited to hear about what you have done over the course of that career. So welcome.
It's good to be here. Thank you for having me on.
All right. So before we dive in, you were telling me before the show as we were chatting, you have managed to pick up an extremely similar job at each of these shows, maybe described as migration engineer. So tell me about that.
That's pretty close. I think that's a pretty accurate description. But I guess let me walk you through my career progression and how I sort of got to where I am now. I started out actually as a front-end developer writing CSS and JavaScript and web views at Yelp. And I found that it was difficult for me to get my job done because I was constantly waiting on back-end engineers to implement APIs or other stuff that I needed. And so I was like, well, I could probably do full stack. I taught myself enough Python to be dangerous and started being a full stack developer. As a full stack developer, I realized, hey, I'm spending all this time waiting on like build tooling or CI or, like linting or infrastructure, those sorts of things. I was like, well, I could probably do that. And so I started a web frameworks team, or at least that's how it was really a developer productivity team, but we called it web frameworks because that was how we got it greenlit. And I started working on developer tools and realized that's the stuff that I really, really enjoyed doing and haven't really looked back since then. I did the same stuff at Lyft where I was hired to build out developer infrastructure. Stripe was a little bit different. I was building specifically Python infrastructure, but again, it was developer tools and making that stuff happen. And I'm currently building that out at Sentry as well.
Right on. I'm curious, do you feel like you missed the I am building the feature as you got deeper and deeper into the I will unblock myself world?
Sometimes it was nice to see the fruits of my labor on a production web app and be like, yeah, I made this page. But after a while, it was like, no, I don't really want to deal with a product manager and having to twiddle pixels for a living. But the big thing for me was like, I was able to be a multiplying factor for other developers, and that was way cooler to me than any sort of user-facing product. Like, it was really awesome to be able to build a tool that made a whole bunch of people, way more productive.
I'll ignore the comments about product managers, but
Not all PMs are bad.
Some of us are okay. I do agree that the feedback loop of seeing your coworkers work on things that you get to implicitly take credit for basically everything the company does, which I totally understand.
Yeah, and you work directly with your users, the other developers at your company, and so you get direct feedback, and you can, see people excited about the stuff you build. Whereas, okay, maybe the A/B test is successful, and that's our users being, excited about this, but it doesn't quite, it's not as direct feedback as I like to get.
Yeah, absolutely. That makes a ton of sense. All right. So this Lyft migration, when was this and what stage was Lyft at?
Sure. So I think the best way to phrase this is in terms of the 2020 end of life of Python 2, which in theory was when you should have been migrated off by. Lyft actually took a little bit more of a progressive approach to this, partially due to my convincing. that we should try and accomplish this before the end of life. That way we were never in a situation where we're on an unsupported version of Python. And so setting the stage, this is probably, the start of the process was probably late 2018, early 2019, where we had decided, hey, I think we want to migrate off of Python 2, and I think we want to try and get it done by 2020. At the time, Lyft was a couple hundred engineers. I don't remember the exact number, but about 50 or 60 teams and a couple hundred services. Probably a similar number of services to... actually, no, I have the number. It was 600 services. So we had more services than developers at the time. Which, yay, microservices.
Microservices architecture in the late 2010s.
Yeah, it got Lyft to where they were. I actually think that it was pretty successful in the approach that they did, and like we built the necessary infrastructure to make microservices work, and so like it wasn't all terrible. I should also talk about the number of Python 2 services. So of those 600 services, some were written in Go, the rest were written in Python, and there were about 150 Python 2 services spread across about 40 different teams.
That is a non-trivial number to run. It was a number to migrate.
Yeah, it was especially large given that the dev infra team was about 4 people at the time, and I think only 2 of us were focused on Python infrastructure. And so realistically, it was kind of like 2 of us plus whatever volunteers we could scrounge together to try and pull off this massive migration.
So was that team given the mandate to go migrate Python, or was that an idea?
So I always like to talk about how our team prioritized and made projects happen, and they really come from 3 sources. One is leadership tells us we need to do a thing. Okay, fine, we need to do a thing. Easy. The other is we collect feedback from developers and figure out what other people at the company want us to do. And then we sometimes formulate those into actual projects, or sometimes we ignore them, to be honest. And then the third is ideas that come from within our team ourselves, where it's like, we know that this is going to be impactful, or we hypothesize it's going to be impactful. How do we spin this to everyone else and make it happen? The Python 2 to 3 migration was actually a bit of a mix of those second 2 categories. Leadership obviously didn't care. We had to convince them as part of making it a real project. But we had a lot of developers at Lyft that were like, hey, my service is stuck in Python 2. I would love some help getting it to Python 3 because I want this feature or this syntax or this library or this tool. And they were stuck in, ye old Python 2 realm where they couldn't utilize those things. But I think most of the push was within our team. We were like, hey, we have a lot of overhead providing developer tools for both language versions. It would be so much better if we could just standardize on Python 3 and move everyone forward and not have to deal with spooky security scenario where, oh no, we're running unpatched Python in production and suddenly there's a 0 day and like we need to somehow patch Python now. We wanted to avoid that as much as possible.
That seems like the kind of situation where suddenly leadership would be involved and care about this migration.
That's the thing about, maybe this is too on the nose, but I feel like that is a common thing about security as a priority, which is like, nobody cares until you get owned, and then it's a P0. Whereas I think a much more healthy approach to security is thinking about it up front and like actually investing in prevention and tackling these things before they're on fire.
Absolutely, it's so if you patch everything that will definitely own you in the future and didn't patch anything else, that would be the ideal scenario. But that requires knowing things that I don't think you can know.
That's also true. Yeah. But until then, it's like keeping the dumpster fire not as much burning as it could be.
Absolutely. So, developer friction, the knowledge that this eventually might turn into a security issue, and your team decided to push for it. So, all right, a lot of services to run. How did you think about the major milestones of this migration?
Yeah, so this was actually pretty tricky because like, I have a prescribed way to migrate to Python 2. I guess I'll talk about how I would do that for a single service. But I think our problem at Lyft was multiplied by the fact that there were many, many services, and I'll talk about eventually the tool that helped us with that. When I think about, well, migrations in general, but specifically this Python 2 migration, it was split up into a couple of steps. The first is, we know we have Python 2 code, we know it's passing its current set of tests. Let's try and get it just parsing in Python 3. Run it through very rudimentary syntax checks and get those passing. There were some amount of things that we had to fix there, like, for instance, async was a valid variable name in Python 2, but suddenly in the Python version we were migrating to, that's a keyword. And so there were modules named async and variables named async, classes named async that suddenly don't work. And so we had to manually go in and rename some of those things. There were also things like the print statement going to the print function. We needed to fix those. Fortunately, there's a tool that we used called, what is that tool called? Why do I not remember? I'll think of it later. But there's a very popular tool. It's based on lib2-3 that helped us do some of the very early syntax based migrations, things that were things that we could automate. Once we had syntax passing, the next milestone was to get linting passing. So run the code through the same validation checks that we were running in Python 2. Things like MyPy or MyPy if we had the chance, but like Flake8 and other linter tools, basically. Once we had linting passing, we moved on to tests. So trying to get the test suite to pass in both Python 2 and Python 3 at the same time. This was sort of important because we wanted every milestone to be something that we could commit and deploy, rather than having one big bang pull request that just cut the ties at the same time. This meant that we had to do a little bit more work because it is arguably easier to have a code base that is only Python 3 or only Python 2. But because we wanted to maintain compatibility and have this smooth rollout transition without any potential scary, oh god, we need to roll back now, but someone's already made a patch to the new version. We wanted to maintain compatibility to make it easier to land each milestone independently. And then once we got the test passing, it was really just try it in production until it succeeds. Roll it out, monitor errors, monitor system health and statistics and other stuff like that. And when it's good, it's good. Most services were successful in the first deploy. I think that was just luck. But I think the worst service we had to roll back and forth 12 times to get it out. But even that wasn't too bad. Deployments were pretty fast at Lyft, and rollbacks weren't a huge deal. And we had designed circuit breakers and failovers for any service that was important enough to need them.
Was there? I mean, when you put something into production and are monitoring errors, that's real user traffic. Was there a concern about the impact of we're testing on real users?
There definitely was. We had a few things in place that mitigated those problems to some extent. The biggest mitigator of those problems is every service went through a canary deployment. So as part of rolling out, you would roll out to a very small percentage of traffic, and that would reduce the blast radius of a bad change. Of course, those are still real requests going to real users. The other thing that helped, that sort of saved those from being catastrophic, even if it were completely broken, was it's a web of microservices. So necessarily we had to bake in retries, and we had established service tiering to say a tier 1 service calling a tier 2 service must ignore failure or whatever, or retry on failure, or have some timeout budget, whatever, to handle a failure scenario there. And so we had sort of avoided this catastrophic failure being a problem just by way of how our microservices were set up. A Python 2 rollout was no different than any other feature rollout. If you rolled out broken code to production, it's sort of mitigated by canary and retry mechanisms. Of course, a tier 0 service, you don't have those same safeguards because you are the front line. Like if it's broken, it's broken. But even in there, like Canary saved things being completely trashed.
Interesting. I love the approach of like you're essentially driving the error rate low enough that the rest of the system can then actually succeed. Mm-hmm. So you're never going to get to 100% success, but you're sort of below the noise floor of what matters to the user.
Yeah, and in any distributed system, something is always broken. So it's not really, it's not different in that regard. We're just, minimizing that brokenness.
Right. That's really interesting. So how did you tell me a little bit more about this idea of you're incrementally committing the migration as you go along? Presumably you didn't stop the world for each of these services and say, we're not going to commit to them. We're not going to do feature work on them. There was some amount of other work happening. How did you weave together, we're going to change half your service, reading the async module with the team's otherwise work?
Yeah. That was actually one of the very important parts of this migration. And I think one of the important parts of migrations in general, which is like, you don't want to stop the world. You want to sort of be, not really a fly on the wall, but you don't want to like derail any feature development that's happening at the same time. And so the way that we did this, or at least the way that we tried to do this, was each incremental milestone that we made in a particular service, we would add automation to keep that, that milestone valid. Like if you made the syntax pass in Python 3 and just committed the syntax changes, they would immediately regress unless you had a system in place to prevent those from regressing. And so for every step that we did, we baked it into the CI setup for that service. So like, okay, your syntax passing, great. We have a syntax checker now in your CI. Your linting is passing, great. We have a new linter in your CI. Your tests are passing on Python 3. Okay, now your test suite runs both Python versions. For this intermediary period. This did mean that some feature requests were maybe a little bit more difficult because now they actually have to do the right things. But I think the impact to developers was minimized as much as possible. We also put in tools that would auto format stuff. So even if you made the mistake, often the tools would fix it for you and you wouldn't have to think about it.
Got it. Where did those tools run? Were they in CI or on people's laptops?
A bit of both. So I'm got a shameless self plug here. I wrote a GitHooks framework called Precommit, which supports linters and code formatters in a bunch of different programming languages. And one of the core ideas of Precommit is it manages the tools and installs them for you so you can run them directly on your local machine, but you can also run Precommit in CI so that it'll run the same set of tools there as well. And so basically, GitHooks are a first line of defense in getting early feedback on things and automatically fixing things, but we also ran them in CI and used the same set of processes in both places to ensure that they don't regress. And so we basically wrote a lot of Precommit hooks to do this, or used off-the-shelf tools that fit into the framework.
Got it. So someone, you probably had some bumpiness if you were in the middle of a feature branch at the moment that you decided you were going to start the Python 3 migration, but I don't know, maybe you shouldn't have long-lived feature branches either, right?
I agree with that. Yeah, feature branches should not be long-lived. But even in that case, like a lot of, imagine you branched from mainline, we introduced a new syntax check. You opened your pull request from an old branch. What would actually happen there, if you're lucky, and you didn't get a merge conflict immediately? If you didn't get a merge conflict, CI would merge with mainline and then run the new formatters that were introduced on mainline, and in theory, automatically fix your pull request for you. We didn't actually implement the automatic fixing, but you would have to pull and run precommit run -h all files, and it'd be close enough to automatic. But a lot of cases, there is a little bit of bump, but we try to minimize it as much as possible.
Got it. Did that... You had this sort of regimented way of thinking about it. So we'll do syntax, and then we'll do lint, and then we'll get the test passing. Was that, on one hand, when you explain it like that, it makes a lot of sense to me. I can't come up with another way to do it off the top of my head that's not obviously just reverse those, and that seems backwards. Why did you pick that particular ordering, and are there other ways of doing a migration that you just decided don't work as well?
Yeah, so in this particular case, we tried to like I like to think about it as a ratcheting. Like we know we're starting at this like air quotes bad state, and we want to get to this air quotes good state. And how do we incrementally move towards there, but put something in place that doesn't allow it to slide backwards? And the particular steps that I chose for this 2 to 3 migration were things that were either easy, automatable, or something we could definitively say, okay, this will not regress because we put this thing in place. I don't think that there's much. I mean, in this particular one, I think this is the way to do it. You could probably skip some steps or combine some steps, but ultimately, like, you have to at some point make the syntax compatible, and at some point you have to make the linting pass, and at some point you have to make the test pass. Like, I guess you could do them in the other order, but this seems like easiest things first, and then hardest things last, and then finally roll it over. You could also take more risks. Like, you could do it in a way where it is a big bang pull request, and you're not, you don't have this compatibility layer that we decided to do. But leveraging my expert opinions here, you're better to stay compatible, and you're better to have smaller feature branches or smaller incremental changes rather than trying to do it all at once. There were smaller services at Lyft that we did combine some of those steps. So like, there were definitely some where it was like, well, the linting or the syntax linting and tests all pass, and I only changed 2 lines of code. Fine, we'll just combine those steps. But yeah, for anything non-trivial, it was useful to split them up.
Yeah, and in saying smaller services, you actually have a natural factoring already. You already are splitting the work kind of vertically across several hundred different services. So do you think that logic still holds if you're thinking about something like a monorepo?
Ooh. So I'm going to be honest. I'm not much of a fan of monorepos, but I actually don't think it really changes much here. Depending on how you handle your monorepo. I think the most naive understanding of a monorepo, which is just it's a repo where you put repos inside of it. It's not really any different than handling microservices in a bunch of separate repos, except that you happen to have everything checked out right in front of you. I do think there are potentially some benefits to being able to apply, like say you wanted to apply the syntax change to every single service at the same time. You could do that in a monorepo in a single patch. I think it would have been harder because you couldn't actually you'd have to do a lot more work in a single patch, or you'd split it up. But if you have separate repos, you just naturally split it up. I don't know. I think what I want to say is it's not easier or harder whether you're using microservices or a monorepo here. It's really based on what tooling do you have to support these types of things in either of those scenarios. Like if you don't have good microservices or microrepos tooling, you're not going to have a good time with microrepos. If you don't have good tooling for a monorepo, you're not going to have a good time with a monorepo. And then it's down to personal opinion about which of those types of tools do you like or familiar with, or gel nicely with your brain structure. And that's where the personal opinion about monorepos comes in.
Yeah, that makes sense. I think there's if you're not only monorepo but you're also monolith, I think then you have a real challenge here. I was talking with some folks who have a 10 million line Python monolith at the core of their application, and one of the things they would love to do is divide it up into separate packages that they could migrate or deal with more incrementally. Yeah, absolutely. Just might have to eat the pain on that one. Do one big patch.
Yeah, monoliths are a perpetual struggle. I think I've encountered that problem at every place that I've worked so far. Lyft actually spent a whole large migration to decouple and what did they call it? Split up their monolith, but they had a funny fancy word, decomp. It was project decomp.
Monolith decomposition is all the rage.
There's the PTSD kind of anyway.
I'm going to get someone from Twitter on the show next.
Yeah.
Really deep. So, all right, you have the set of tooling. You've got your factory. Did that tooling create any further problems? Did that automagic commit hook framework get in anyone's way more than it helped?
Well, I can talk about one of the things that went wrong. I don't think it was really the fault of the linter formatter framework, but more of the fault of we didn't know what we were doing in production. So actually, let's take a step back because we didn't talk about how we even tried to federate these out to all the repos, because I think that's important to frame this first. Lyft wrote this internal tool called Refactorator, and the basis of Refactorator was a database. I use the term loosely because it was actually just Google Sheets. An executor, which I use that term loosely as well because it was just a Jenkins job, and a series of automatic fixes. And what it would do is you would write this automatic fix, you could write tests for it, etc. And Refactorator would check out every repo at I almost said Sentry, every repo at Lyft, and it would try and apply this check. Or it would try and apply the change. And it would also see whether it was already completed or whether it failed or whatever status it was. And it would generate pull requests for them. And then it would store all of this information in the Refactorator database, and you could view like the status of what all of the pull requests were at. And so we had this like giant spreadsheet of every single service and each of those stages that we had. And so we could kind of make this, you talked earlier about splitting by vertical. We actually had vertical and horizontal splitting literally in a spreadsheet to figure out the status of this migration. And a lot of this was us just writing these automations, doing that part once and just letting it rip and, sending it out to all the repos. We had a bit of I would say we had a policy, but it was sort of unwritten policy of like, if a refactorator did not get merged for a while and no one said no, then it must have been good enough, and we would self-approve and merge them. And surprise, surprise, people are not, most people are not on top of reviewing external pull request changes. Like, they're usually pretty good about reviewing people from their team, but an outside pull request, it slips through the cracks most of the time, especially an automated pull request that comes from a bot. So
not the top of the heap.
Yeah, I think we had the hardest time getting these automated things merged. But anyway, we'll talk about one particular thing that went wrong, which was when we first did our first phase of automatic formatting, like basically taking code and saying, okay, we're going to run. Damn, why can I not remember the name of that tool? Hold on, give me 1 sec, because I'm going to remember
sure.
This. Because I want to give credit to it. Based auto formatter. What was it called? Oh, come on, really? Upgrading tools. My tool is mentioned there, but not the one I'm thinking of.
Well, what use is that?
Right? Maybe it got removed because it's broken, because lib2-3 got removed in modern Python. Modernize. That's what it's called. It's called Modernize. Okay.
That makes sense. That's a good name.
It's a great name. Yeah. So our first pass was to run Modernize and PyUpgrade. PyUpgrade is a tool that I wrote. On the code bases so that they would be syntax compatible with Python 3, and they would remove any legacy Python, like pre-Python 2.7 syntax. Because Python, like pre-Python 2.7 syntax was a lot harder to make compatible with Python 3. And so that was kind of our first phase, and this was to get syntax compatibility. And we wrote through Refactorator, we sent it out to all the repos, we waited a week, and then we auto-merged any of the ones that didn't have test failures or people complaining about them. They had a week. They should have responded. Some of them were 2 weeks. Some of them were 3 weeks. Like, we gave people ample time to notice the changes and respond to them. And one of our services was a wild data pipeline thing that I don't think anyone really understood how it worked. And it was the specialist of snowflakes in our service graph and infrastructure. It ran on some third party that we were paying a bunch of money to run our service there. Don't really know why. But as this automated refactor, which passed tests and passed linting, got merged and rolled out and broke this production app. Not only did it break this production app, nobody noticed for like 3 or 4 days. So a whole slew of things had to go wrong here. The reason that it broke this production app is our assumption, and the thing that was written in the code base that it was running Python 2.7 was factually incorrect. It was actually running Python 2.6 like 4 years after, actually probably even more than that, after the 2.6 end of life. Let's see.
Did anyone tell security at any point?
Once security noticed, they were very unhappy. But yeah, so then we had to roll it back and do a whole bunch of work. Okay, it was 7 years past the end of life at that point, because Python 2.6 end of life in 2013. Man, what a throwback. But yeah, so, a whole bunch of things had to fail there. Like, the repo thought it was running 2.7. It definitely was not. The tests thought they were running 2.7. Definitely was not. The linters thought they were running 2.7. Definitely was not. There was no monitoring production. So if it was broken, the only way you would notice is by actually looking and noticing. And yeah, all those things lined up to be a pretty unfortunate situation. But I think the good and the bad of it is that was the worst thing that happened in this rollout. It was just that one service.
Wait, so 3 days in, the service isn't running. Nobody has noticed.
Yep.
At that point, I would assume it would be down for weeks. What? Somebody did notice.
Someone did notice after 3 days, and oh no, you've imperiled the data pipeline was the words that they used when, which became a little bit of a meme amongst my friends. Anyway, someone did notice, not due to any monitors or anything, but they had just like tried to check the output of some model that they were running, and there was no output, and they were like, wait, this should have been here. Why is it not here? Dug into it, found that the app wasn't running, and then went from there. There was screaming and shouting involved, but that's a company culture problem and not a migration problem. That's
wild. I'm trying to think if there's anything. It feels like where to start. How did the test and linting pass in that scenario? It feels like something should have broken, or I don't understand computers as well as I think I do.
Yeah, so the reason that it passed is the repo itself assumed it was running Python 2.7. It had no idea that production was a completely different version of Python. And because of that, like the build, actually it is a miracle that it succeeded all, because the build product that it produced targeted 2.7, and it happened to just run and be successful in 2.6. Like, well, a lot of times you can have syntax compatibility and you can have library compatibility. It was just getting lucky.
Mm-hmm.
And then unlucky, but
so was the fix, what was the fix? Do you just need to run it on 2.7 in production?
Oh, we went through a whole bunch of stuff with that because, well, as soon as security noticed, they're like, what the heck? Also, the version of 2.6 that was running wasn't even the latest patch version, and so immediately we were scrambling to like either apply security patches to get it to the latest 2.6 or get it to 2.7. The other part is we didn't control the machines it was running on. They were running on this like third-party vendor that provisioned them, and they had limited network access and like all sorts of weird stuff. So the first thing that we actually did was build 2.7 as an ETL job. So like run a C compiler in this bespoke third-party environment. And so then we had a blob that was the Python 2.7 interpreter and its standard library and stuff. And so we could ship a little Python 2.6 shim that would bootstrap 2.7, and then now that service is actually running 2.7. Was at least to get it to a place where we have some amount of we're grounded in truth now.
Mhm.
And then we used the same process to make that service run Python 3 once we had done the rest of the migration process. But we had to do some wild stuff to get it to even a normal state of running a supported version of Python.
That's if your production environment is not what you expect, I just it's amazing that anything works at all.
Surprise! I have to say, running a C compiler in an ETL job is probably not the wildest abuse of a data pipeline I've ever done. One of my first projects at Yelp was actually using MapReduce to resize every business photo at Yelp. Because MapReduce was the easiest way for us to get really cheap compute, and well, you can sort of the map was trivial, and then the reduce was side effects in S3.
That is not the worst. Honestly, it feels like a very map reducible problem.
Yeah, but the reduce didn't actually reduce anything, and the map didn't actually map anything. So it was really just a like parallel for loop with convenience.
Yeah. All right. So let's talk a little bit about the kind of scale out of this of this process. So you end up with a set of tooling, mostly running through Refactorator, Modernize, cleaning up people's code bases. How much, if you were to put a percentage on that, how much of that automation actually worked successfully? And then what did you do for the stuff that didn't?
Yeah, so and actually I think this is a good target number to hit for any sort of migration. We were right around like 80 to 85% successful purely from automation and with no human input. Which is extremely high. Like
that's great.
We got pretty lucky that the code wasn't completely terrible. That last 10 to 15% was, or 15 to 20%, whatever percentage is remaining. We had to do some manual work. And the way that we sort of organized this was we had the two people from developer infrastructure that were working on this project, and then we recruited people from teams that were what I like to call infra-minded or sort of wanting to learn more about other stuff types of people. And we organized basically little... I forget what we called them. They weren't typing parties, but it was essentially the same idea where like we would check out a meeting room and we would hang out for a couple hours and, crank through all the manual parts. And because we were all like right there and, in person, we were able to quickly say, hey, have you seen this particular case before? Yeah. Oh, here's what you do. Here's how you fix that. Yeah, this code got copy pasted from over here. So apply the same fix that we did there. And we were able to basically like, have a team of about 5 people accomplish all the manual things. The other nice thing about these infra-minded individuals was they were often able to turn this around and be like, hey, look at this thing that I did to accomplish this company initiative that looks well in a promotion packet.
It is not to be understated how much that drives behavior and influence and the way projects get done at all.
Especially at Lyft. Lyft was very heavy on the like promotion grind set.
You get what you incentivize. I don't think that's controversial.
Yeah. Impact.
I do love the idea that there's almost this cascading set of, you had a team working on things, but you didn't recruit the entire organization. You recruited these 5 people to come inside. How were there other layers that you thought about sort of beyond that of spheres of influence or groups that you needed to convince?
Yeah, the early part of the project, like before we even started working on it at all, I spent so much time convincing people. And a lot of that was like, a lot of it started with me going to my friends that were on feature teams and being like, hey, this is the thing that we want to do. Help me build some, like, it sounds like it's something that you would want. Like, let's build some evidence that this is something we actually want to accomplish, and help us get some like quotes that we can use in a proposal document for leadership and such. And so we started as like, grassroots, going around to people and being like, hey, what do you think of this? How is this going to work? But convincing a bunch of engineers is easy. Convincing, engineering managers and directors and leadership is way more complicated and a lot more work there. I think the biggest thing that we were able to convince people with is we had done one service as just kind of like a trial, and we were mostly successful entirely with automation, and so that helped us go to leadership and say like, hey, yes, this is a huge project, but we don't think it's going to impact people's day-to-day work that much. We think we can accomplish this with a small tiger team of people. We think that automation is going to be key here, and we're going to be mostly successful just from automating stuff. And I think that when you go to someone and say, hey, the cost is low and we get these benefits, it's a lot easier to convince someone than saying like, oh yeah, we're going to need one engineer from every team to work on this full time for a quarter. That's you do not pass go, do not collect $200. You're never going to get that project off the ground.
Yeah, absolutely. I've been on the other side of that table, and you sort of get like 1 or 2 tokens per company per quarter for that kind of project. And man, I hope your project is the one that makes it if you're going to ask for like 1/10 of an FTE from every team. Even though FTE math is not accurate, but we all do it. And 2 FTEs spread broadly is very different than like, we're going to spend 2 people on this and they're just going to finish it.
Yep. And how do you manage your spoons?
Yeah. We're going to have these people, they're going to write automation, and to prove the automation works is huge. You don't work there anymore, so you can answer this honestly. Was that estimate correct?
We completed by 2020. The estimate was very close to being correct. Like, I think there were probably like 5 or 10 services that slipped beyond the deadline. But a lot of those slipped not due to our team's process, but because they had a very important project that required them to block pull requests in the repo for that period of time. And so like, even though our PRs were passing tests and they explicitly said, no, we're going to wait till we ship this large feature that we want to roll out. And we're like, okay, fine. Your feature is going to make money. Ours doesn't, and we had sort of agreements with them that they were like, we will follow up immediately after this to merge these and roll these out and make sure that's successful. But yeah, our estimate was actually very close to being correct. We started, I want to say, Q2, it's fiscal quarters, so garbage, but like February of 2019 with a goal of hitting September of 2019, give us a couple of months of leeway in case we slipped. And I think we had almost everything done by mid-October.
That's pretty close.
A little slow, but most of it was just like 5 or 10 services at the end. And given there were 150 services, like, we were pretty close.
There is reasonable evidence that if in large companies, if you bring in an outside consultant to modernize your services, that something like 80% of those projects simply never complete, and they're giving themselves 5 years at a time. So a 6-week slip seems fine, honestly.
Yeah. Easy.
Sounds great.
And change the unit, double the number. Like, we didn't even do that. It was pretty much just like, this is what we think the work is. We just multiplied it out from our example service and turned out to be pretty close.
That's having that knowledge of doing one first is just so key. That makes a lot of sense. All right, couple minutes left, so we'll do quick fire to wrap things up.
Cool.
All right, if one technology never existed, what would you choose?
Like, I can delete any technology from existence?
Gone, off the map.
Wait, I can only pick one though. That's really tough. There's so many I would like to delete. Man, that's a tough one. I don't want to say something too spicy, so maybe we'll go with something a little less spicy. And some pain from a previous generation. So it's dead now, and so I can just retroactively delete it. I'm going to say ActiveX.
There is, I think, a lot of people who already believe ActiveX never existed. We're not going to remember that time.
Which is great. Because it was miserable to develop for. Oh.
Oh, that's great. I love it. What was the one tool or feature of a tool that you didn't decide to write during this migration because it just wasn't worth it?
We had started trying to do like a parallel execution of both language versions in production mode, where we were going to like run 2 and 3 for a long period of time and compare their like CPU memory usage and stuff. And like we had sketched out like the deployment system to make this possible. We were basically going to duplicate every capital D Kubernetes deployment and like run them side by side. And we just said, screw it. It'll just be, just a normal pull request. Will be simpler anyway. And so we didn't end up pursuing that. But it was in our back pocket if somebody wanted something a little bit more cautious of a rollout, a true blue-green comparison. But we didn't need it, so we didn't build it.
No, that stuff is much more typical for database migrations. That's a must-have if you're going to do something stateful. But yeah, that makes sense. I understand.
We were lucky that everything was stateless, so we didn't have to do anything too complicated like that.
And last one, if folks have more questions, where can they find you on the internet?
See, I've actually deleted most of my social media. Well, I'm going to shout myself out as an alternative. You can find me on YouTube at Anthony Writes Code, or on Twitch at Anthony Writes Code as well.
Right on.
And that's probably the easiest place to find me.
And folks should definitely check out your stream. It's awesome.
Thanks.
Cool. Well, thank you so much for coming on. This was really fun.
Yeah, I'm always happy to chat about these things, and it was really enjoyable chat with you.